Hello everyone, and today we'll be talking about Use It or Lose It, Characterizing Water Right Diminishment in Washington State Documents. And to start, my name is Jaime Jacob. I'm currently a rising senior at the University of Michigan, pursuing a double major in computer science and environmental science. And this summer, I was an Ag Aid intern at Washington State University Pullman, working with Dr. Kirti Rajagopalan and Dr. Matt Yorick. And essentially, there are over 6,400,000 irrigated acres of farmland in the state of Washington, and in some parts of the state, like near the Snake River, there are only 7 to 9 inches of rainfall annually, which makes water a very valuable resource, and therefore water rights are very important because they determine how much water can be used, where it can be used, and how it can be used. And today we are going to be looking at the annual quantity that is determined in a water right document in acre-feet per year, which is the total quantity of water that may be diverted or withdrawn in 1 year. And there are 2 doctrines that govern water rights in Washington. The first one is called first in time, first in right, where a person who established a water right first has senior priority and the right to divert all of their water before the person with the next junior right. And the second one is called use it or lose it, where a water right may be wholly or partially lost through extended periods of voluntary non-use, which can result in water relinquishment or change in annual quantity due to non-use. So essentially, if a person who owns a water right doesn't use all of the water that they are allotted, then the water that they do not use can be given back to the state for other beneficial purposes. And in Dr. Matt Yorick's project, he has been going through all of the state of Washington documents to calculate the water diminishment by hand. And to do this, we need to find the existing water right, the existing annual quantity, and the board-approved annual quantity, and the difference between the two. So here we have 2 different formats of water right documents, but there are a variety of others that can occur throughout the state, and water relinquishment can happen in any of them despite the format. So on the left, we can see that the existing is 1,215 acre-feet per year, and the board-approved is also 1,215 acre-feet per year, which I know is hard to see. So when we zoom in here, we can see that there is no difference between the existing and the board-approved. Therefore, there is no water diminishment in this document. And on the right-hand side, in Franklin County, we can see that the existing use is 160 acre-feet per year, and then the board-approved is 155.9 acre-feet per year. Again, we can zoom in, and we can see here that the difference is around 4.1 acre-feet per year, so there was water diminishment in this example. And the problem here is that there is currently no way to do this other than by hand, which is extremely time-consuming. So the goal of my project was to create a program that can accurately identify water relinquishment in a water right document. Therefore, we could curate a well-informed database that lawmakers can use to make more informed decisions regarding such a valuable resource like water. And here's a quick overview of how I did this. To start, the Washington Department of Ecology has a database that contains all of the water right documents, so we acquire those, and then we put them through technology called optical character recognition to transcribe the PDFs into TXT files, and then we use the TXT files to create a vectorized database, which we then use for retrieval augmented generation to query data using OpenAI's API large language model. Once we get the large language model response, then we calculate the water diminishment in the document, and then we calculate the accuracy by comparing it to Dr. Matt Yorick's hand-calculated water diminishment per document. So a little bit about optical character recognition. We had to use it because the PDFs from the Washington State Ecology database were scanned images. Therefore, they were unusable for analysis, so we had to transcribe the PDFs into TXT files. And we opted to use Amazon Web Services TextRact, which automatically extracts text, handwriting, and data from scanned documents. Here's a quick example of how OCR works. So on the left, we have the original PDF, which is a scanned image, and on the right, we have the OCR output, or optical character recognition output. As you can see, a lot of the tabular structure is lost once this is transcribed into a TXT file, and this poses a bit of an issue for us, as we are looking for annual quantity. On the left, it is easy to see that the annual quantity is 36 acre-feet per year, but if we zoom in, it's a bit harder to tell on the right-hand side because so much of the structure of the document is lost. So this definitely drags down our accuracy a little bit in the coming parts of this project. After we transcribe all of the PDFs into text files, we then upload them to a database and then query that database using OpenAI's API and retrieval augmented generation and rule-based retrieval. So retrieval augmented generation essentially means that we upload all of our files to a database, and then once we query OpenAI and we query its large language model, its context to answering our question comes from our database instead of its knowledge base. And then rule-based retrieval means that we can filter which document from our database that the chatbot can pull its context from. So therefore, we can do one document at a time instead of pulling from all of our documents in our database. So here's a quick example. It says, what is the existing maximum acre feet per year in Franklin County? And the answer is 160 because I specified that it should be pulling from this document. And as you can see, 160 acre feet per year is the correct answer. And a little bit more about Franklin County. Once we pull around 50 documents or so, we asked the chatbot 3 questions of each document. We said, what is the existing maximum acre feet per year? What is the board accepted maximum acre feet per year? And was the proposal accepted? Once we got the answers for each document, we calculated existing minus board accepted to find the water relinquishment in that document and compared the answer to Dr. Matt York's hand-calculated answer that he had already done. And then this helped us calculate the accuracy of around 59%. And when there was no relinquishment or there was no change in annual quantity, then there was around a 77% accuracy. And when there was relinquishment or there was a change in annual quantity, then the accuracy rate drops to around 7. And we can attribute a lot of this inaccuracy to the transcription of the OCR. So OCR is a useful tool to pull text from scanned images, but we definitely need to do more exploring in the future to find a product that maintains the tabular structure of our documents, especially because Franklin County has a lot of the tabular structured documents, so therefore that could definitely drive down our accuracy rate. And then another challenge that we ran into was with the custom chatbot itself. It's great at interpreting context and it's easy to set up and use, but it's not great at pulling from a specific document, which is why we had to use rule-based retrieval as a workaround. And some implications of this project is that once the accuracy of prediction is improved, this could become a useful tool to compile databases for further analysis, which would provide accessibility of historical documentation, allowing for more informed lawmaking around such a valuable resource such as water. And then moving forward, the next steps in this project would look like us exploring image recognition software more deeply so that we could preserve the structure of the documents during transcription and therefore improve our accuracy rate as well. And we'd also like to expand our data set to compare different styles of documents and how the program may perform differently. And with that, I would like to give a big thank you to the Ag Aid Institute for having me this summer, and also both of my mentors for guiding me through this project. And thank you to everyone else that made this summer so wonderful. I had such a great time and I learned so much. And I would like to say thank you. Are there any questions?